Greetings. My name is Ojas Kasbekar, and welcome to our third homework for the course Design and Analysis of Reconfigurable Systems. Today, we will learn how to use an IP on Terasic board to calculate trigonometric sine and cosine functions. So let's begin. As always, we started by making the project, then we selected the cortex sine cosine calculating IP to generate the Verilog script. The basic script is auto-generated with some basic inputs denoted by A, which is denoted in radians. Now, please keep in mind that A is a 10-bit input with first most significant bit indicating the positive and negative sign. The second and third MSBs stand for the decimal values between 0 to 3, and the rest 7 are the decimal values. We also have the reset clock inputs and sine cosine as outputs for each 5-bit outputs. As the pin on the board are active low, we have negated the A reset here. Now this is the test bench. As you can see, we have defined a few parameters here. We'll be giving the phase as our input. Now let us run the simulation in Questa. It selects the input output pins. Okay, so as you can see, these are our waveforms. We shall convert all of them to binary from hex values. Yeah. Now let's zoom in. Now the default value of C cos when we have zero radians input should be 1, and that is what we see here. As for the sine function, it's 0. We give radians input equivalent to pi. We see the output. We see cos input go to 0, sine inputs go to 1. We do see there is a phase difference here. The cos function also starts at a different time with respect to sine. So we can say there is a 90-degree phase shift between both of them as in the trigonometric function. After this, we'll be seeing the demonstration of this simulation on our FPGA board. So as we can see, we have given binary inputs. Initially, right now, the inputs are at 0. The first 5 pins are cos. The next 5 LEDs are for sine. Now let's give pi as input. So as you can see here, we have given binary equivalent of pi. We can see that the first bit, which denotes negative sign, is lighting up. The result of the cos value is -1. The sign was 0. Now, if we change the bits to -pi, we can now see that the results are exactly the same. Cos is still -1 and sine is 0. Next, let's calculate pi by 2. Now, we can see that sine is 1 and cosine is 0. Now, if we give the bits for -pi by 2, we can see that for -pi by 2, cos is 0 and sine is -1. Now let's calculate the values for pi by 3. As we can see, for minus for pi by 3, the cosine value is 0.5. It's infractional, and the sine value is 0.875. Keep in mind that these are not absolute but approximate values, as Cordic only has 8 options to choose from when it comes to output for fractional values. So that's all for now. In the next part of the project, we'll be displaying the same results on 7-segment display for better readability of the results. See you then.